We may or may not be doing some fun activities in class to get us through some of this, but this is the nuts and bolts of how our sides and angles and things of our triangles are related. So I think I think these are silly names of theorems, but if one side of a triangle is longer than another side, then the angle opposite the longer side is larger than the angle opposite the shorter side. That is a whole bunch of words to say. If this is the longest side, then that's the largest angle. If, I'm trying to, hang on, I'm going to erase my scribbles. If this is the shortest side, then that's the smallest angle. Smallest, opposite, smallest. If you think about it, it kind of makes sense, okay? And the opposite is also true, though we don't call it a converse, we call it its own theorem, in that the smallest angle is opposite the smallest side. So if you know the smallest angle, then you know which side would be the smallest. This is true in any triangle, not just right triangles, because you might be thinking, well, we know the hypotenuse, right, is the longest side and it's opposite of the 90-degree angle, which is the largest angle in a right triangle. So this concept isn't necessarily new to us, but we're now saying it's true in every angle, in every triangle. Whatever that largest side is, angle is, it's opposite the largest side. Now, we need to list the sides in order from shortest to longest, but we only know two angles, except that we know that all three angles add up to be 180. So we can figure out that angle F is 180 minus 51 minus 47. So angle F must be 82 degrees. So that means that angle F is opposite of the largest side, right? So the side DE would be the biggest. And then next would be 51. So that would mean that EF would be next. And then 47 would be the smallest, so that would mean that DF would be the smallest, which means that we actually did this backwards as it says shortest to longest. So we did it in backwards order. Same difference. So we'll do it right this time. So from shortest to longest, but we need to find that angle. So we're going to do 180 minus 61 minus 59. And we're going to get that C there is 60 degrees. Okay. So they're all very close, but not quite. So the shortest side would be opposite of the smallest angle. So BC would be the shortest. And then our 60 would be next. So AB would be next. Notice we could have called that BA. Doesn't matter in this situation. And then opposite of 61, which is the biggest angle, would be our AC. So yes, you could have said CB, BA, CA, same difference. Okay, now, this is confusing to me. This is confusing to me. Here's how I say it, which is not too far off of what it actually says, but the two sides, any two sides of a triangle have to be bigger than the length of the other side. So you cannot make a triangle that has sides 1, 1, and 2 because 1 plus 1 is not bigger than 2. Okay? Usually we look at the two smallest to see if they're bigger than the third, because if they are, then everything else will work too. So make sure you write this down. I don't know where I paused again. I am so sorry, y'all. So follow the math, and x has to be greater than 5, right? And it has to be less than 23. Well, that's a weird way to write that, isn't it? Whichever way you want to write it. Usually we write the lower on the other side. Okay, so it's a range that x is somewhere between those two numbers. It could be anywhere. Okay? So notice that basically we subtracted those two numbers to get the 5, right? And we added the two numbers to get the 23. Keep that in mind. So we've got these two side links, 6 and 15, right? If we subtract them, we get 9. And if we add them, we get 21. Well, x has to be somewhere in there. Has to be less than 21, greater than 9. So we subtract, we add. That's it. This long, confusing way to say subtract them, add them, you got your range. Oops, that's all I got. Holler if you have questions.